Hi, I'm Norm Abram. Welcome to the new Yankee Workshop, where today we're going to build this sturdy student's desk, meant for your best student. It's built with high-pressure laminate and accented in oak. It's a lot of fun to build, and I'll show you how right here on the new Yankee Workshop.
The new Yankee Workshop features the craftsmanship of Norm Abram.
Hi, Lindsay.
Hi.
Got a lot of homework today?
Yeah, I'm working on selenorates.
Selenorates. I'm glad it's not me. Now tell me how your new desk is working out.
Well, I keep my note paper and my pencils in this drawer, and my school books in this drawer.
Now, how about the file drawer?
Down here, I keep all my manila folders.
Oh, good. And it seems to be the right size, the right height,
Yep.
and there's enough room to spread everything out?
Lots of room.
Well, you know, if you take good care of this, you'll be able to take it off to college.
Well, if I'm going to college, I better get back to work on selenorates.
Well, am I holding you up?
Just a little.
Well, it's a fun project to build. Let's go out to the shop and get started. One thing I can assure you is that this desk will last forever because we used long-wearing materials. The high-pressure laminate is practically indestructible, and the red oak that forms the perimeter and the frames is very strong. So if you'd like to build one of these for your home, a measure drawing is available with the materials list, and you'll hear more about that before the program ends. Now, I'd like to take a moment to talk about shop safety. Be sure to read, understand, and follow all the safety rules that come with your power tools. Knowing how to use your power tools properly will greatly reduce the risk of personal injury. And remember this, there is no more important safety rule than to wear these safety glasses. Now, I want to get started on our project today by laying up the laminate for the top and the end panels. Each panel consists of two components, the high-pressure laminate itself and the particle board substrate. The particle board is about 3/4 of an inch thick, and it's sold at the home center as countertop blank material. It comes in sheets 25 inches wide and up to 12 feet long. It's the perfect material for a laminate because it has a nice, smooth surface. What I have to do is apply a contact adhesive to the substrate and to the laminate. And when the adhesive dries, I'll simply bond the two pieces together. They will not come apart. The contact adhesive I'm using is a choice of professionals because it really works. But as it says on the can, it can be explosive and it contains harmful vapors. So I'm going to take a few precautions. I'm going to wear this mask, which is fitted with a chemical cartridge for organic vapors. I want to make sure that there's plenty of ventilation in the workshop while we do the laminate work. There'll be no flame anywhere near the work area, yet the room must maintain 65 degrees or better for the adhesive to cure properly. To apply the adhesive, I want to get a nice even coat. I've used a brush in the past. I've even taken scrap pieces of laminate and just spread it around. But when I went to pick up my laminate, I found a roller cartridge that's specifically designed for applying contact adhesives. And it works pretty well. Well, let's see if it's dry. You can tell when it's right, when it's just tacky to the feel. Not over dry and it doesn't come back on your finger. When I sized the laminate, I made it slightly larger than the substrate, and I'll trim off the excess later. What I want to do is very carefully position this because once it goes down, there's no moving it. And just set it right down on the substrate. And then I want to use this tool, which is a very important tool. It's a J roller. Because of the small diameter of the roller, I'm able to put a lot of pressure down to complete the bond. I always start in the center of the piece and work my way to the edges to push out any air that might be between the pieces. Now here's a strategy for handling the larger pieces. Because the laminate is so flexible, it's hard to position it exactly over the piece. So what I want to do is use some scraps of wood, and as long as there's no adhesive, it won't stick to the contact cement. And by putting a whole series of these out, I'll be able to set the laminate on it, position it first, then pull out the cleats. This really works great. You can just set the piece down on the strips, making sure that there's a little bit hanging over each edge. Okay, then I'm going to start in the center, removing the strips and starting that bonding process. To trim off the excess laminate that overhangs the substrate, the router is the tool to use, and I've equipped it with a flush trimming bit. The little ball bearing will ride against the substrate, and the cutter will remove the material. The base of the desk has 6 legs, and they are assembled into frames, one on this end, one on the other side of the drawer case, and one on this end. The rails of each frame are joined to the legs with mortise and tenon joinery. The best tool to make the mortises in the legs is my stationary mortising machine. I've set it up with a 1/2-inch chisel with the appropriate bit and adjusted the fence so that as I make one pass, turn the piece end for end, and make another pass, the mortise is centered 3/8 of an inch from the edges. The front legs on each side of the drawer case also need a mortise to receive the tenons from this lower rail. The laminate panels sit in grooves that I've plowed out in the oak. To make the groove, I'm using my router shaper table, which I've equipped with a 3/4-inch straight cutting bit. I've adjusted the fence so that when I run the rails, I'll make one pass through, turn the piece end for end, make the second pass through, and that gives me a groove that's perfectly centered and the same width as the panel. Now for the legs, it's a little bit different. Because I don't want the groove to exceed the mortises I've made, I put a little indicator mark for the top of the mortise here and the bottom of the lower mortise down here. I've installed some tape on my router shaper table to define the bit. What I'll do is lower the leg in the mortise area over the bit, push it along until I get to the other mortise, stopping at the line. Turn it end for end, run it through the same way, and again I'll end up with a groove perfectly centered and the same thickness as the panel. Now that first pass was about 1/4 inch deep. The final depth that I want is 1/2 inch. I dare not do more than 1/4 inch with the hardness of that oak. I've removed the desk top and turned it around so that you can see the back of the drawer case. This leg and this one over here have the mortises and the groove for the side panel. But in addition to that, there's a groove that runs from the top of each leg down to the lower mortise, and that'll receive this panel right here and the tenons from the rails. Now I'm ready to make the tenons on each end of the rails. There's a series of shoulder cuts to make. The first one being 1/4 inch deep on the side opposite the groove. After raising the saw to make a cut to a depth of 3/8 of an inch, I'll make 2 shoulder cuts, one on each face. Well, now for the cheek cuts of the tenon. And for that, I'm going to turn to my tenoning device, which is a heavy tool that rides in the miter gauge slot of the saw. Now I want to plow out a groove in several of the rails. I need one in the top rail of this end panel to receive this assembly, I need one in all 3 rails of the drawer case to receive this piece, and also all 4 rails of the bottom for this bottom panel. I want to show you a detail at the bottom of the legs. It appears as if the desk is just floating up off the floor. And that's because I took some time to round over the edges of each leg so that as the desk is slid around, it won't chip. My router is set up with a 1/4-inch radius beading bit with this little ball bearing on it. First thing I want to do is make a pass on opposing sides. Okay, that takes care of 2 edges. When I made that pass, I was able to depend on the bearing to go the entire section of the leg. But if I try to do the short end, what's going to happen is the bearing is going to follow the profile I just cut instead of just going straight across. So what I'll do is bring the router in somewhere in the center of the leg, then use a combination square to act as a guide against the base of the router so that as I move it, the bit will stay parallel to the edge. Well, now we can assemble the panels. A little bit of glue in the mortises and some on each tenon. And just slip those in place. Oh, that fits nice. Okay, well, I'll put this in a set of clamps and let it set overnight. Well, the glue joint's set up nicely overnight, and these are very strong panels. But before I go ahead and do any more assembly, I want to take the time to sand the joints nice and smooth, because it's a lot more difficult when the piece is all together. Well, let's start assembling the drawer case. First, I'm going to put one of these back lower rails in. And then a back panel, which is glued in all the grooves. Now the top rail. Now this slot is for the bottom panel, and this is a very important panel for the drawer case because it'll keep everything from racking. Now you'll notice that I made notches in each corner of the panel, and that's so it'll slip by the legs. Okay, and here's the lower front rail. Now these small pieces that go at the top of the case are notched to fit around the leg, and they will allow me to secure the top later, and they also hold the top of the drawer case together. Some more glue applied to the other frame, and we'll set that on. Okay, now let's check it for square. Okay, that seems to be pretty good. While the drawer case sets up, let's get to work and make this particle board frame and the back oak rail and attach it to the remaining end frame. Because I don't want any fasteners to show and I want maximum strength in each joint, I'm cutting biscuit slots. These slots will be the ones to join the oak piece on the back. I'll also cut slots where the frame joins together. Well, now I'll just join the oak to the side frame and the particle board. Okay, well, while that's drying, we'll start working on the top. Now, here's the pieces of oak that will surround the laminate of the top. And I want to make a rabbet for the laminate to sit in. I'll make that with 2 passes through the table saw, first making this cut. A couple of adjustments here for the second pass. The corners of the oak are joined with mitered joints. I've cut one end. Now I'll bring it over to the top and mark it for length. Okay, now I'll just slide the mitered end down until it's perfectly even, right there. Come up here and mark this end. With all the pieces of oak properly fitted, I've laid out for biscuit slots that I want to cut, both in the top and in the oak banding. To strengthen the joints at the miters, I'm also going to install some biscuits. With biscuits and glue in place, let's fit it together. With enough clamps in the right positions, I should be able to get the joints to come together nice and tight. With some more glue and biscuits, I can attach part A to part B of our base. Now here's a finishing touch on the base. I'm putting a strip of oak over the particle board edge, just to conceal it, using biscuits and glue. And one last piece at the top of the drawer case. Let's start building the drawers. This is one from the prototype. It consists of a plywood box made out of cabinet-grade plywood, which is attached to the drawer front, which is made from particle board, banded in oak, and with a laminate applied to the front. Now the box has dovetail joinery at the front, and at the back I need a dado to hold the back piece in, and I'll make those first. That's just right. Now I've narrowed my dado head cutter down to 1/4 inch in width and readjusted the fence so that I can cut a groove down the side of each side piece and front piece to receive the plywood bottom. Now using my dovetailing jig and my router, which is set up with a dovetailing bit and a guide collar, I'm able to make the tails in all the side pieces. Here I've installed a drawer front in the top of the jig, and by flipping over the fingers of the template, I'll be able to cut the pins. With glue applied to the joint, all I have to do is drive it home. I like to put the back in next. The bottom is just put in dry and secured with a few nails. Now let's build the draw fronts. To cover the edges of the particle board for the draw fronts, I'm using thin pieces of oak that are mitered at the corners and attached with glue and brads. Sanding the edges of the oak smooth to the particle board assures a good bond for the laminate. Well, now I have a couple more things to do to the desk top. I want to round the edges, top and bottom, with a 1/2-inch radius. These little plywood blocks will provide better holding power for the screws that will ultimately attach the base to the top. Well, now I'll center the base on the top and attach it with some screws. I have to install these pine strips. They're like fillers, any place there's a draw slide. Okay, that works good. Now I like to put the draw fronts on last because if my slides are just slightly off, I can adjust it with the front. So what I do is I set it in the position I want with about the right space all the way around, and then just draw myself a little indicator line on the back side. Then I'll pull it out and attach it with some screws. Now that kind of dresses it up a little bit. Good. All right, a little touch-up sanding, and we're ready for some finish. We started to finish this piece by putting on a coat of sanding sealer. Then I gave it a light sanding, dusted it all off, and now I'm putting on the first of at least 2 coats of gloss polyurethane. One of the things I really like about this student's desk is that it's virtually indestructible. It should last for a long time. I hope you enjoyed building this student's desk. For a catalog of all the New Yankee Workshop projects, please write to the New Yankee Workshop, Post Office Box 9345, South Burlington, Vermont, 05407.
The New Yankee Workshop is made possible by
Delta Woodworking Machinery, a full line of precision shop tools available at woodworking dealers, hardware stores, and home centers. Delta, building on tradition.
Porter Cable, professional power tools made in America and available through woodworking dealers, hardware stores, and home centers.
and by
Vermont American, the blades, the bits, the tools to make American workmanship better. Vermont American, the power in power tool accessories.